Welcome to the Mathematics MI channel. Today we are going to solve another interesting integral. Integral from 0 to infinity e to the minus x times natural log of gamma of 1 minus e to the minus x dx. Okay, first I am going to take this integral is equal to I. Now first we can take a substitution. So if we take u is equal to e to the minus x, now differentiate, so du is equal to minus e to the minus x dx, and lower limit when x approaches to 0, we know u approaches to 1. When x approaches to infinity, upper limit u approaches to 0. Okay, now we can plug in here. Now our integral I is equal to, now limit 1 to 0, natural log of here gamma of 1 minus e to the minus x, we know u, so gamma of 1 minus u. Now here we have e to the minus x dx, so e to the minus x dx is equal to minus du, so minus du. Now we can change the limit, lower limit and upper limit, 0 to 1. When we change the limit, this minus get cancelled, so we can write natural log of gamma of 1 minus u du. Okay, again we can take a substitution. So if we take, now here 1 minus u, so I'm going to take 1 minus u is equal to v. Now differentiate, minus du is equal to dv. Now we can write this is equal to, now lower limit when u approaches to 0, v approaches to 1, upper limit when u approaches to 1, v approaches to 0, natural log of gamma of 1 minus u, we know v, and du is equal to minus dv. Okay, again we can change the lower limit and upper limit, so we can write here this is equal to 0 to 1, natural log of gamma of v, and this minus get cancelled, here dv. Okay, now we know this is also equal to I. Now we know the King's property of integration. So 0 to a f of x dx is equal to 0 to a f of a minus x dx. Okay, so we can write this is equal to 0 to 1, natural log of gamma of, now instead of v, 1 minus v, here dv. Okay, we know this is also equal to I, and now I am going to take sum of these two integrals. So 2 times I is equal to 0 to 1, natural log of gamma of v plus natural log of gamma of 1 minus v dv. Okay, then we know the property of natural log, so we can write here this is equal to natural log of gamma of v times gamma of 1 minus v dv. Okay, now we know this property of gamma function, gamma of x times gamma of 1 minus x is equal to pi over sine of pi x. Okay, therefore we can write our integral 2 times I is equal to 0 to 1, natural log of, now instead of gamma of v, gamma 1 minus v, we can write pi over sine of pi v dv. Okay, again according to property of natural log, we can split this integral into two integrals. So 0 to 1 natural log of pi dv minus 0 to 1 natural log of sine of pi v dv. Okay, here natural log of pi is a constant, so natural log of pi, here dv, integration of dv, v 0 to 1, so 1, here 0. Now we can take a substitution again. So if we take pi v is equal to t, now differentiate pi dv is equal to dt, and lower limit we know here v approaches to 0, so t also approaches to 0. Upper limit v approaches to 1, so t approaches to pi. So 0 to pi natural log of sine of pi v is equal to t, and dv is equal to dt over pi. So dt, pi we know constant, so 1 over pi. Okay, now natural log of pi, here we know here upper limit we can divide it by 2, so we should multiply by 2, so 2 over pi, here natural log of sine of t dt. Now natural log of pi minus 2 over pi, and we know this is a famous integral, and in a previous video we discussed about this integral. We know the answer is minus minus pi over 2 natural log of 2. Okay, now this pi get cancelled, this 2 also get cancelled, and now we have natural log of pi plus natural log of 2. So we can write here this is equal to natural log of 2 times pi, here 2 times I, so I is equal to 1/2 natural log of 2 times pi. Now according to property of natural log, we can write this 1/2 as a power of 2 pi, so we can write I is equal to natural log of square root of 2 times pi. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.